Let's work a problem of an explosion and conservation of momentum. In this problem, we have a rifle that initially has a bullet inside. The rifle and the bullet are the system. So the system has two objects that are initially at rest. So the velocity of the bullet at the initial time is 0, and the velocity of the rifle at the initial time is 0. After the rifle shoots the bullet moves to the right, and the rifle will kick back to the left. If we choose as the positive X direction the direction to the right, as indicated in the diagram, then the bullet is moving at the final time at 300 meters per second to the right, so the velocity is positive, and the rifle will be receding with a negative velocity that is unknown. And we would like to know what is the velocity of the rifle, the recoil velocity at the final time. So this is clearly an explosion example, and momentum must be conserved, so we can apply conservation of momentum. So we know that the final momentum must be exactly the same as initial momentum. Now, what are the components of the final momentum? We should have the momentum of the bullet moving to the right, so we have the mass and velocity of the bullet at the final time, and the second object of the system is the object, so we should have the momentum of the rifle times the velocity of the rifle at the final time. This is the final momentum of the system. Now, the initial momentum. What is the initial momentum? Since we know that the velocity of the bullet at the initial time and the velocity of the rifle at the initial time are both 0, initial momentum will be 0. We want to find the velocity of the rifle at the final time, so all we have to do now is isolate the velocity of the rifle at the final time. So we move the first term to the right side of the equation. On the left it's positive, it will go as negative to the right, and then we divide by the mass of the rifle, which is multiplying the velocity of the rifle on the left side. It will go dividing to the right side. And then all we have to do is substitute values. So the final velocity of the rifle is the mass of the bullet, which is 5 grams, or in kilograms the mass of the bullet will be 0.05 kilograms, multiplied by the final velocity of the bullet, which is 300 meters second to the right with positive sign, divided by the mass of the rifle, which is 3 kilograms. After we do this math, what we will get is that the final velocity of the rifle is negative 0.50 meters second. So this is the result of our problem. This is the rifle velocity at final time. We can add that since the sign of this velocity is negative, this means the rifle moves to the left, because we said that the positive direction was to the right, so the negative velocity indicates a motion to the left. And we are done with this problem.